Okay guys, welcome to conceptrecap channel, and today we shall look at some examples on separable differential equations. So if you have seen the PDF that I sent in the description for the separable differential equation, then those are the questions that we are going to look at. I will be sending in advance so that you can look at them before you watch the video. And if you haven't, then the PDF is also in the description below of this video, and you can go ahead and download, and then you can look at it. And so we shall start. Our first question will be so if you haven't attempted it, you can pause the video and try to find the general solution of this differential equation. So here it's separable. So as usual, you are going to separate as the first step, and this becomes okay. This becomes what? This will go to this side. This will go to this side, and this will come to this side, and this goes to this side. So that's how you are going to do it, and you will remain with y dy divided by plus this, and this will be like that. So then the next step is you introduce the integral. You integrate. So how you are going to do that is you integrate both sides. So you have like this. So the right hand side is easy because it's ln x, while this one, so you can use U substitution to solve this part. And I'm going to put the solution for U substitution, but we use a different method. The method is the one I'm going to show you just now. It will be like, because you have y plus 1 here on the denominator, so we are trying to make this also y plus 1 to be also on the numerator. So if we add plus 1 here to make this equation the original, then it will be like this. It will be like this, minus 1, like that, so that we don't change the equation. So you have something like this as usual. Then we can go ahead and put for this side as ln x plus c, because it's the last side. You can just put constant there, and then you can see here that this is just the same as the original equation. So what you can do here now is that what you are going to you are going to separate. So this is what you are going to do. You will this you are going to say, because this y plus 1 is a common for two fractions, like this, then it will be minus 1 over y plus 1, like that. So dy. So you are going to copy this side. So you have something like this, and obviously this will cancel. So it will give you 1. So the integral of this side of this guy will be what? Will be this will be 1. So the integral of 1 is what? Is y. So it will be y minus, this will be ln y plus 1, like this. So this will be your integral. So as you can see, guys, we have managed to integrate to find the original solution, using this of this separable differential equation. So if you got this answer like this one, please let me know also. And if you got a different one, let us know also. Maybe we can try to help you where you didn't understand. So let's see another example, guys. So our second example, as in the order of the PDF, is this one. So if you haven't attempted it, then when I write, you can just pause the video and try to solve it. And if you have done, then let's watch together if you got the same answer. And if you have a problem, you can ask always in the comments. Or if you have another question about separable differential equation, you can always send me to my email, and I'll put it in the live stream session. So we will solve it there as you're watching. And so this is the question. And as usual, this is also separable. So, and then you are going, the first stage is to always write this as dy dx. So this will be dy dx. And this will be like this. So then now you can separate. And how you are going to do that is easy. So you have seen that the x's can go to this side, and this can go to this side, and the y's will come here. So that's how you separate them. But considering that you don't violate mathematical operations, so this is how it will look like. So you have dy, and this, when this x comes here, then it will be 1 over x, and this y comes here, then it will be dividing. Then you can write it as like that, and you will have x here. So this, it will be like in the denominator, so you can raise it like that, and then you put your dx like that. So we have managed to separate. Then you are going to integrate. So how you are going to do that is you integrate both sides like that, and for this one, the integral, you know, you are going to add 1 here, and you divide by the denominator, the same thing. So for this side, it will be minus 2 minus 1, it will be minus 1, then this will be negative, so it will be 1 over y. So it will be like this. And for this side, you are going to use integration by parts. And by parts, you remember the formula is, the formula for integration by parts is what? Is this one. You have integral of u dv minus is equal to uv minus v du. So how you are going to select your u's and v's, then this depends on, normally I use this concept. Let's say this. So we're just going to do that so that it helps us to identify which one is our u. But so we have got algebraic here. So this will be our u, because this is an exponent, is the last one. So our u will be x. So du will be dx, because you differentiate, and therefore the other side, this guy will be dv. dv will be ex dx, and Therefore, v, you integrate. So if you integrate this, it should give you minus ex, like that. Because if you differentiate ex, e to the x, it will be e to the x, and it's chain rule. So you differentiate the inside, it will be minus 1. So this minus. So that's why if you enter this minus and that minus will cancel, then it will give you positive. So we are correct. So we will now take them back to our substitute this parts thing. So you are going to put u, then it's x, and v, it's minus. So we can just put minus. Okay, I can put minus here. Okay, let me just. So it will be minus x to the to the e to the x, then it will be minus, then dv v du. Our v is minus e to the x, and du is dx, like that. So this will go out, then it will be 1 over minus x, like this. So this will be positive. Now the last, now you can integrate this, so it will be minus. So minus and minus, it will be positive. So this becomes, it will be now minus, because yeah, so it will be now minus ax and your constant, like that. So now your answer is, you can like reciprocal to find what is y. So your answer should be y is equal to minus 1 because of this minus as it comes here. So it will be minus x e to the x, and e to the x plus c. And our third example is as this. This is in the same order as in the PDF. So again, friends, is that you can pause the video and attempt it. And if you have any question, any comment, anything to say, you can write to my email, or you can write in the comments below. I'll be answering that as well. So this is the question. So as usual, you are going to do what? You are going to write this as dy dx. So you write this as dy dx. And it's good that you should be practicing, because normally by watching doesn't help. So this is from experience. If you just watch, sometimes it doesn't help. You may think that you understand, but you don't. So it's good you practice. So when I say you pause the video, you should practice, so that in an exam you have more speed, and your hand will be kind of familiar with what is going on. So now what you're going to do is you copy the rest. So the next step is to separate the stuff. So how you're going to do that is the x will go to this side, and this also goes to this side. So you remain with so now this is the separation, and what you're going to do now is to integrate the third step. So you go ahead and integrate both sides. Now for this side it's easy, because you're going to add 1 like this, and you divide by the same thing. So now your integral here will be y to the third over 3, and you not put the constant, because we have a constant here. So constant plus constant gives you a constant, or constant minus constant, it gives you another constant. So just leave it. So for this side, then you are going to use by what? By parts. So again, we are going to write our equation for our formula for parts. So it is u dv minus u is equal to uv minus v du. So, and our u, according to what we said, you see that the first what comes is algebraic, because the other one is trig. So you start with algebraic. So your u will be this x. So u will be x, and then du will be dx, and dv will be this stuff. So it will be cos dx, and the v you integrate, and then to remember about integration and differentiation of this stuff, I can give you, I use this circle. I just draw like that. So you have here sine, and here you have cos, and here you have got negative cos, and here you have got negative sine. So that's it. And if you are differentiating, you go clockwise. If you are integrating, you go anti-clockwise. So like here we are integrating, so cos, if you integrate cos, you go clockwise, then it's sine. So in that way, you not be confused. So it is sine x. And now you have everything. You go ahead and copy it here. So this becomes that. So u is equal to x, and the v is equal to sine x, and minus, and the v is sine x, dv is du. The du is dx. So like that. So now you are going to proceed by copying for left hand side, and then you have got x like that, and then the integral of sine is here. So you go anti-clockwise, so it's minus cos. So minus minus, then it is plus cos. So, and then you add your constant, because you have finished. So this is the answer for this particular problem. So guys, that's it. And then we have one more example. So what happens is, you have initial conditions. This pi means it's the value of x, and that means when pi is x is pi, then y is 0. So you go ahead and pause the video, you try to solve. So let's start attempting the question. You have what you see is, you just separate as we do normally. So you have x equals dx is equal to this minus 6y dy. So that's how you are going to separate. It's easy. And the next step is, the second step is to introduce the integral both sides. And again, this is by parts, and we looked at it, this one. So our u is x. So for this side, our u will be x, and our dv will be cos dx. So you are going to say u is equal to x, and du is equal to dx, and dv is equal to cos x dx. Therefore, v will be sine. So, and then we have everything. So we can rewrite this as x, which is u, and then sine like that, and then minus, you have v as like this, and then dx. So this is the left hand side, and the right hand side is, you separate, you integral of 1 dy, and then this, so integral of y dy. Okay, so you have integral of this, it will be y, and you have integral of the others of this stuff, it will be, because if you add 1, then it will be 6, cancel, then it will be 1 to the 6, like this. That will be, but we have initial conditions. So according to what I told you is that you include the conditions. So the conditions are, you are supposed to write them here. So you have, as x is pi as the initial condition, then this is x, as we did. So you have here, it will be 0, and there will be y. So that's how you do that, and you maintain them here as well. So it will be pi 0 x, and then it will be 0 y. So you know how we do that. But there's another way. The another way is the one you know, whereby you can find the general solution, and then you find for c, then you substitute that c into the general solution. So you can try it. You find that c is equal to 1, and then you substitute back into the general solution. You find that it's the same thing. So now if you are going to substitute, let me finish this one. So you have x sine x. So this sine x, if you integrate sine, then you go anti-clockwise, then it will be minus cos. So it will be now plus cos x, like that. So you have your pi and x as your conditions. Then here you are going, because you are going to subtract by 0, then it's just y minus y to the 6. So because if you put in the conditions, that's what you get. And for this side now is that you put, for the first one, it will be the way it is. But now for the second one, you're going to say minus. So minus, if you put pi here, so sine of pi is equal to what? Sine of pi is 0. So this becomes 0. This becomes 0 if you put pi. And the cos of x, I mean cos of pi, cos of 0 is pi, cos of 0 is 1. So cos of pi is minus 1. So, and then it will be minus 1, and this will be 0 minus 1, like that. So you copy this side. So then you finish by saying that x sine of x plus cos of x, then it becomes plus 1 is equal to this is what you get. So like I said, there's another way that you can use. So that's it, guys, and we shall have our first live stream whereby we'll have some questions. These are examinable questions, and check out on that one as well. And if you have other extra questions on separable differential equations, write them to my email, and we shall have another live stream. Because as for now, you may find it that I have already recorded it because I still don't have funds as of yet. So that's it, and thank you for watching, and see you next time, and goodbye.